This is skill 8.4, using interior angle measures. So the goal is that from that 8.3 investigation that you just completed, that you figured out what the formula is for figuring out what the total interior sum of any polygon is. So hopefully you got it. Hopefully you've kind of checked on that, talked to someone, made sure that you were able to find that. But if not, it is this. The sum of interior angles of any polygon is equal to the number of sides minus 2 times 180 degrees. So I would write down that formula regardless of if you were able to figure that out on your own or not. And then we're going to define what those two variables mean as well. So this S stands for the total sum of interior angles. And the N stands for the number of sides in the polygon. All right, so we're going to be using that formula as we go through this lesson, so it's important that you have that down and you're able to use it. So the first two examples ask us to find the interior angles, or the sum of the interior angles of a pentagon and a 17-gon. So a pentagon, we need to first write down the number of sides, so n. n is equal to 5 in a pentagon. Okay, so from there, we just need to substitute 5 into our little formula. So the total sum is equal to 5 minus 2 times 180 degrees. Okay, now you can do that all at once. You can punch that into a calculator, or you can do 5 minus 2 first. 5 minus 2 is 3, and 3 times 180 is 540 degrees. So our total sum is 540 degrees. Okay, 17-gon, same idea. Let's just make sure we can handle one more. So n is 17. That's pretty easy. It tells us right there. And then we're just going to use sum equals 17 minus 2 times 180 degrees. So again, you could type it in a calculator altogether, or you can do 17 minus 2, which is 15, and 15 times 180 degrees is 2,700 degrees. So obviously, the more sides that your polygon has, the higher the sum of interior angles is. Okay, now for the next set of examples, we're kind of going in the reverse order. So they're giving us the sum of interior angles, and we're asked to find out how many sides that polygon has. So we're going to use that same formula, but this time they are giving us the S. Okay, that is going to be the S in both situations. Our job is to figure out, what is n? How many sides are there? That's what the variable n stands for, so that's what our job is. So when we go and use our formula, I'm just going to write it down one more time. S equals n minus 2 times 180 degrees. This time, we're not going to substitute anything in for n. We're going to substitute something in for s. So in our first case, we have 1,260 degrees equals n minus 2 times 180 degrees. Okay, now easiest way to solve this, fastest way to solve it is probably not to distribute. We could distribute the 180, but I would just divide both sides by 180 degrees. Okay, what that will do, if we do 1260 divided by 180, we're going to get 7 equals n minus 2. Now we don't really need the parentheses anymore, so I'm just going to kind of get rid of those. Pull down n minus 2. Our last step then to get n by itself is to add 2 to both sides. So we end up with 9 equals n. So the number of sides is 9. If you wanted to, or if it asked you to, you could write down what kind of polygon that is, and that would be a nonagon. So the interior sum of a nonagon is 1,260 degrees. All right, and then we'll just go through that process one more time in case you need to see it. So again, we're replacing S with 8,100 degrees. We're going to use our formula that says we subtract 2 from n and multiply by 180 degrees. From there, easiest thing to do is divide both sides by 180 degrees. And one thing I didn't talk about in the last example either is when you are dividing, see how we have degrees on top and degrees on bottom? Those actually kind of cancel each other off. So that's why we don't have degrees anymore, and we don't want degrees because we're looking for number of sides. So 8100 divided by 180 gives us 45. So 45 equals n minus 2. Add 2 to both sides, and we get 47 equals n. So wow, that is a polygon with lots of sides. We don't have a very good name for that, so we're just going to call it a 47gon. All right. And then last example here, this one has a little bit more algebra in it. So they say name the polygon and then solve for x. So if we're naming the polygon, the first thing we want to do is count the sides. So I'm just going to kind of mark them so I remember that I counted it. So 1, 2, 3, 4, 5, 6 sides. So n is equal to 6, and that's a hexagon. Okay. And now how the heck are we going to solve for x? Well, we first need to know how many degrees we should have inside of that polygon. So we first need to figure out what that total sum is. So let's do sum equals 6 minus 2 times 180 degrees. And we're going to find out that our total sum is equal to 4 times 180, which is 720 degrees. Okay, so there's kind of a lot to this problem, a lot of problem solving, a lot of math going on with this one, but we can't solve for x until we know what that total sum is. Okay, now what we can do is we can go around and we can add together all of our angles. Now I don't want to write down every single thing, so I'm just going to go through and first add up all the variables. So 5x plus 4x is 9x, plus another x is 16x, plus 8x is 24x, plus 6x is 30x. So as I went through there, I ended up with 30 x's. Then I'm going to go through and count all the constants. So we have 120 minus 6 would be, let's see, 114, plus 14 would be, let's see, we had 114 plus 14, we'd be at 128. And then we're going to take away 8, and we're going to end up right back at 120. So if you kind of double check that, we have a negative 8 plus a negative 6 is negative 14, plus 14 is 0. Okay, so really we just have that 120 that we started with. So that looks good. Okay, and altogether, that should equal 720 degrees. So all of our angles with our variables and our constants should add up to 720. Now we can solve it. Subtract 120 degrees from both sides. And we have 30x is equal to 600, I believe. And then our final step would be to divide by 30. So 600 divided by 30 is 20. X equals 20. So I believe there will be one like that on your assignments. It'll take you a little bit, but totally doable. So go ahead and complete the 8.4 practice. And as always, let me know if you need anything or have any questions as you work through those.